My presentation is a response to Chapter 12 from Ramachandran's book, Phantoms in the Brain, and it is about information integration theory, a suggested approach to the problem of consciousness. Ramachandran ends the book by circling back to the origins of psychology, which is found in philosophy. In his discussion of qualia, he's talking about what is called the hard problem of consciousness, which is the question of how the physical substrate of the brain can produce experiences that seem to be purely sensational and subjective. He's putting forth some really challenging concepts that are taken up in a field called neurophilosophy. Neurophilosophy has a lot of ancestors, but it was really characterized by Patricia Churchland, a philosopher at UCSD and the Salk Institute. A central argument is whether cognition is simply the brain performing formal operations using symbols, which is known as computationalism, or if it can be modeled using connectionism, which focuses on the interaction between the environment and various brain regions. Neurophilosophy is also a branch of philosophy of science, and in this area attempts to understand how neuroscientific methods work and if they're valid. One of the most famous papers in this field came from Thomas Nagel, who asked this question in 1974. What is it like to be a bat? This is fundamentally a question about qualia, or what Nagel calls the subjective character of experience. Since bats are mammals, we assume they have some form of consciousness. While we might imagine what it's like to live on fruit, sleep outside, and use sonar, we cannot really know what it's like to be a bat, because that is fundamentally a personal experience. We only know what it is like to be ourselves. Everything else is speculation and inference. Nagel's thought experiment was met as a challenge to a purely materialist, reductionist approach to consciousness, which by necessity discards any subjective experience because it isn't physical, it isn't mechanical, there's no way to approach it directly. This is essentially to say, the brain cannot possibly produce experiences that are more than the sum of its parts. An alternate view of consciousness considers it an emergent phenomena. Interestingly, a lot of the literature I read did not specifically use the language of emergence, but it seems to be applicable here. Emergence is defined as a process outcome that is more than the sum of its parts. Under this paradigm, the brain is a complex system that produces experiences that cannot be explained by looking only at the modular units of the brain. In the same way that swarming behavior by bees can't be explained solely by the behavior of individual bees, but by these exponentially interlocking and radiating behavioral feedbacks. Now, it's entirely possible that we can have both, that emergence of consciousness can be a fundamentally mechanistic process, and we just don't understand the mechanism yet. One theory that attempts to uncover this mechanism is information integration theory, which was developed first by the neuroscientist Julio Tononi, and is now considered one of the most feasible approaches to understanding phenomenology of consciousness. IIT essentially says that any sufficiently complex information system can be conscious under the right conditions. Consciousness essentially is information, integrated and reduced to one state out of many possible options. It's said to be top-down because it starts with phenomena, with qualia, and works back to the brain to identify its substrate. Tononi suggests that it's possible to quantify how much integrated information is in the brain at any one time using mathematical proofs that incorporate phi. In neural network programming, systems with the highest phi are highly complex and include networks that are discrete but interconnected, which also describes the brain. As we say in system science, complication is not complexity. The way a system organizes itself and how exponential its outcomes can be is what determines complexity and thus emergence. Does this theory really do what it purports to do? In particular, can you really hope to come up with a number using phi that tells you how much consciousness you have when you're performing surgery versus when you're stoned in front of the TV? Does this really account for qualia? My partner is a mathematician, and I talked to him about this a lot. He was confused about how the math would work out because you don't usually end up with more on the right side of the equation than you start with on the left. I said, yeah, it's like 2 plus 2 equals 5, and he said it's more like 2 plus 2 equals yellow. So there's plenty of room for skepticism on this. This is why it's called the hard problem. So I went to look if it had been applied, and I found a couple of studies attempting to do so. The Ferrarelli team in 2010, following up on a study in which TMS had been applied to subjects during in-REM sleep, decided to replicate this protocol on subjects under anesthesia when consciousness is far more suppressed. In both studies, they applied TMS pulses to the premotor cortex. In the sleep study, TMS induced arousal in the region of the brain being stimulated, and this information was integrated throughout various regions of the brain under spreading activation. In an anesthetized state, the TMS spike was brief, disintegrated, and localized, indicating a loss of effective connectivity, also known as integration. And you can see that in this image. The top part is the study during in-REM, and the bottom part is the study under anesthesia. This was believed to give credence to the concept of consciousness as an organized, integrated flow of information across discrete brain regions. This paper is a review of psychedelic research and its support for IIT. The psychedelic state is described as a richer, more flexible state of consciousness. The flow of information between neurons is more highly disorganized, which increases entropy and uncertainty. Concepts and symbols and even senses can cross over and make connections they wouldn't otherwise. This picture here is from the paper. It's of the delightfully named reality cone, and reflects that psychedelics widen the possibility of past and future states of the brain. This expansion may account for some of the therapeutic value of psychedelics currently being established, in that it provides the brain an experience outside of inflexible and circular modes of thinking. That's a quote from the paper. Psychedelics reduce organization during the experience, but afterward there is greater organization between networks. Perhaps this is due to greater conceptual linking between qualia. Gallimore compiled a number of correlates to account for subjective experiences in the psychedelic state that might account for the physical substrate of qualia. This requires more research, but is incredibly insightful for its really unprecedented attempt to blend mechanical and qualitative aspects of consciousness. I consider the correlate of states of non-zero probability to be perhaps the most critical here, as this increase in uncertainty and entropy would seem to be largely responsible for the broad overlap of concepts, symbols, and sensations under psychedelics. And inversely, a decrease in uncertainty and entropy are required to organize and constrain cognition in everyday life. That's also a quote. In conclusion, I would say that IIT seems to offer incredible resources and possibility for understanding the physical substrate of qualia and consciousness. Thanks for watching.